Let's get started. Hello, everyone, and welcome to today's deep dive webinar. I'm Shay Levin, and with me, Daniel Morris, Solution Center for R&D, and also Guy Barak, which is the owner of the solution from R&D. Daniel will start the brief overview of the Gateway Load Balancer 2-hour mode solution, and then I will take you through a full deployment from start to finish. Please feel free to ask your question in the Q&A during the webinar, and we will answer them at the end of the session. And let's get started, Daniel.
Yeah, hi everyone. My name is Dan Morse. I'm a cloud security architect. So today I'm going to cover 2-hour mode gateways in a gateway load balancing solution for AWS. So why is 2-hour mode better? And I'll explain to you what the difference is around this. So first off, this solution is a additional solution on top of the traditional gateway load balancing solution that we have within our product platform. The one-arm solution does currently tie into as an endpoint or into the transit gateway. The issue with the single-arm solution is that there's additional NAT cost overhead around the NAT gateways for egress traffic. And this is one of the major concerns that customers always brought to us was that, as traffic's leaving, they incur additional egress costs within the AWS infrastructure. So we designed the solution around eliminating the NAT gateway. So one of the reasons why we chose this is elimination of the NAT gateway. Also provides full blade supports. The one-arm solution, or the traditional gateway load balance solution, actually has a single interface and actually in a bridge type of configuration. Due to that, there are restrictions around the blades that are supported. With the 2-hour mode, the restrictions are no longer there. It's more of a traditional firewall in that approach. Also, traditional routing in the sense of a on-prem or let's say HA environment where you have a one in, one out. Same type of configuration where the 1-hour mode is more of a, as I mentioned, a bridge in and out one single interface. Direct internet egress. So what I mean with this is that traffic leaves the firewall and it's netted and off it goes externally. Also, symmetric routing by design. So both directions flow simultaneously and always hit the same gateway in same instance. And also cleaner operations. So we're on troubleshooting and debugging out of the box. It's easier to kind of identify some issues. Logging is all contained with a single device. A little bit easier to troubleshoot if you need to. So 6 major items reason why we chose or we want to choose 2-hour mode solution. Let's talk about the cost and capacity advantages around this. So first off, the 1-arm solution. Traffic inspected, returns to the gateway load balancer, routed to NAT gateway. So what I mean with this, and we'll see the diagrams a little bit further, is that it gets inspected by Check Point. We send it back to the gateway load balancer, and off it goes to a NAT gateway per AZ. Due to that, the NAT gateways incur costs. There's 2 sets of costs you have on a NAT gateway. One is processed traffic. So every gigabyte is approximately 0.45 cents a gigabyte, and there's also an hourly fee. With a 2-arm solution, that is no longer the case. There's no need for a NAT gateway, multi-AZ support, hourly costs, traffic costs on NAT gateway costs. So a major advantage there, and that could be substantial depending on your environment. Also lower latency, because you are removing a NAT gateway from this, in theory, you have fewer hops and you decrease the latency, simpler routing tables, so easier to actually also troubleshoot. Also simpler architecture. Fewer managed services, fewer points of failure, fewer route tables, fewer operational overheads, a lot of advantages there. So you're actually reducing the complexity of your environment itself. On top of that, I also mentioned is that the constraints of a 1-arm solution is bridge mode. Traffic enters and exits the same interface. And that could limit you on the supportability of some of the blades, where the 2-arm mode provides the full routing stack for a traditional firewall. All the advanced threat prevention blades, IPS features are fully supported because it is a traditional firewall versus a bridge interface. So let's look a little bit more into why you want to choose a 2-arm. So There's no reason really to move from a one-arm mode if you have an existing environment, unless you have some needed requirements. First off, you need the additional advanced features that a bridge mode firewall can't provide. I would suggest, two-arm mode. Cost optimization, you do egress traffic, and you have additional NAT overhead costs, or using, let's say, another device out to the internet, you want to simplify it. You want to go more of a traditional approach, cleaner audit trails. You talked about building of scale, so the consistency and consistency of different architectural changes and a hybrid consistency across your cloud. So they're all valid reasons. But why do you want to still choose a single arm mode? Simplicity is priority, so fewer components. One component that we do have within a two-arm mode, I'll talk about it a little bit later, is to deploy a second interface. We do require a Lambda function. I'll go a little more details into that. If you don't need all the blades and you're happy with the solution with the current the way it is, and maybe your egress traffic is going out a different exit, maybe through a direct connect, or maybe another VGW, or some route to a different location. There's really no need at that point to maybe migrate over to a two-arm solution, or it really both have its equal advantages in different ways. So this is a very flat layout of what a one-arm solution looks like. On the far left, you have your work environment. So let's say your VPCs for your apps and your databases. You get a transit gateway. This is one type of setup you could have where all the traffic hits the transit gateway, and the transit gateway then makes the decision where things go next. And then on the right, we have something called, I call it a security VPC, or more traditional approach security VPC. And you'll see that there are 4 sets of subnets in there. You get your transit gateway attachment that's needed for the transit gateway load balancing endpoint attachment, which is used for the gateway load balancing endpoint. Then you have your checkpoint private interface, which is off of ETH0, and then you have a NAT gateway. In the middle, of course, is the gateway load balancer. So as traffic goes through, this is a single arm mode. Traffic says, I want to go to the internet. So based off its route table, hits the transit gateway. Transit gateway says, I'm going to go to a gateway load balancing endpoint over in the security VPC. That sends it to a gateway load balancer. That sends it to an active checkpoint firewall. This is where things get a little kind of a little messy on a single arm solution. Now it wants to go to the internet. It says, I need to go back to my gateway load balancing subnet. And then, as you can see, then it hops over to the NAT gateway and then out to the internet. So it's more of I won't call it asymmetrical, but it's not a very nice symmetrical type of setup. But it is required because the firewall can't go externally for the traffic. So we do leverage a NAT gateway for this. This is the traditional current firewall solution we have right now. What's different with the two-arm mode, same diagram, but we removed the NAT gateway and we replaced it with a public gateway subnet. And we actually have the firewall has an internal ETH0 and external ETH1 interface. So same concept. No changes here from the AWS side. Traffic wants to get to the internet. It goes to the transit gateway. The transit gateway sends to the gateway load balancer endpoint, sends it to the gateway load balancer, and the gateway load balancer sends to an active firewall on ETH0. This is where it's different. Instead of sending it back to the gateway load balancing subnet, we are actually forwarding it internally across to ETH1. We're doing a source translation to the IP address of ETH1, and we're sending it to the IGW, or Internet Gateway. And by doing so, we eliminate the NAT gateway itself. The packet seen on the destination is actually seen by as the source IP address of the firewall. What's also an additional feature with the two-arm mode is we have something called IPAM, which is an IP pool that you could associate to your autoscale group in AWS. So that means that you could have a list of IPs that you could whitelist on your destination, and your firewalls will always have the same pool of IPs all the time. So a nice feature in the sense that if you scale up and scale down, you always have the same set of pool of IPs that are usable for your environment. So let's look more of a kind of a deeper level. So this is more of a graphical review of it, sort of similar instead of the flat approach. Same concept here. Single arm firewall has a NAT gateway on the right. And same thing with the 2-arm mode. We just have the attachment of a secondary interface on the public subnet side. So let's talk a little bit about, let's say, east-west traffic. In this situation here, traffic wants to go, between the app, VPC app, and the VPC database. If you currently have this configured with your single-arm solution, it's going to be the exact same for your 2-arm solution. Traffic's still going to hit the transit gateway, forward it to the gateway load balancer, endpoint, firewall, and return path. So no difference here, except for when you go to the internet, it transfers the IGW. Couple of differences that are kind of beneficial that some customers have a lot of questions on last sessions we did this is about different types of inbound traffic. So inbound traffic necessarily does not change from your 1-arm solution to your 2-arm solution. These are just some examples here of a centralized NLB, ALB. So that's your load balancer, network load balancer, application load balancer that has its own spoke. So the top left here. Traffic will come in, to the NLB, ALB, and then based off its routing tables, we'll send it across the transit gateway, and the transit gateway sends it to the checkpoint for inspection, and off it comes back into the destination. This is the same as a single arm and a 2-arm solution, but this is just a kind of a layout and how it would look like. Which is one example some customers may configure. Also, one called distributed inspection. So instead of leveraging a transit gateway, customers may have some VPCs that are not connected to the transit gateway, but still need inspection. This you could do on a single arm solution, and you could also do on a 2-arm solution. Traffic would come in through the IGW on the left-hand side here, hits just your NLB or ALB, and then it goes to the gateway load balancing endpoint. So this is basic routing that's required for AWS. And then that endpoint is you could actually deploy these endpoints in multiple different VPCs within the same region. And that the endpoint then sends it to a gateway load balancer, gets inspected by Check Point, and then returns back to the same path to the EC2 instance. No difference from a single arm or a 2-arm solution. For today, it's just kind of demonstrating different architectural sides and how you could use the 2-arm solution. And if you want to take it one step further, more of a hybrid approach. Right, you have your kind of your centralized ingress with some, let's say, some web services down here in the EC2. But when it comes in, you want to get inspected. But you want to inspect it before you send it to the EC2 instances. So you can have an endpoint, and it gets send it across to a gateway load balancer, gets inspected by Check Point, and then hits the EC2. Now let's say the EC2 needs to go, hit the database servers, let's say some database content. It could actually then go across the transit gateway link, send it to Check Point, cross the same path, like east-west, get inspected, comes back, and then hits your EC2 instances. So just another example of a hybrid gateway load balancing distributed infrastructure. But for single arm mode or 2-arm mode, this is very much the same. As I mentioned earlier, we do use Lambda. This is basically a small little piece of code that gets deployed during the deployment mechanism, or if you use your CFT or your Terraform. The reason why we need a little piece of code to actually deploy 2-arm successfully is that AWS limits one network interface for a auto scale group during a launch. So you need to attach a secondary interface afterwards. So to do so, we decided to use a Lambda automation for this approach to add that second interface as the interface goes live. We really were focused on security first approach and also simplicity around this. So there are different stages on how this works. So first off, what does Lambda do? As I mentioned, an auto scale group says, I need to launch a new instance. So, scales up, scales in, maintenance mode, whatever is happening, it says, I need a new instance. Once the instance is brought online from the auto scale group, so as soon as it gets created or starts to get created, there's something called a lifecycle hook within AWS. So during the lifecycle hook, we actually pause the continuation of the deployment, And there's something called an event bridge that says, hey, the VM is in a pause state, or not really a pause state, but a deployment state where it's not going to be functional. And then we have something called the event bridge in AWS executes the Lambda function. And the Lambda function then says what subnets I'm in, what network interface I'm in, which interface it is, which interface to use, and says, oh, I need a secondary interface and I need a public IP associated to it. So then it attaches it and it could pre-allocate it from its IPAM pool if it wanted to, assigns it to that VM. So that VM now is in a kind of a stall state for deployment. Lambda executes it, adds a second interface, adds an IP address to it, and then says, hey, all my checks are good. I can continue on my deployment. So that it enters in service mode with two interfaces. Some key points with the Lambda. Lambda only ran during a launch of an instance. So it is a single execution only when an instance is executed. It does not involve any of your routing, traffic, purely configuration only. The other neat thing behind this is when an instance is terminated, we also ensure that IP goes back into the pool. So either it could be your IPAM pool or AWS pool, doesn't matter. There's no traffic to the gateways until the lifecycle hook is completed. So if the Lambda fails for some reason, let's say, a piece of code, somebody accidentally removed it, it could be many different scenarios out there where it may not work. The box won't go into production without that being completed. So you're not worried about the box receiving traffic and not being able to do anything automatically. And it's also event driven, right? So it only will be triggered when there's an auto scale group event for deployment. So it only runs when it's needed. The other neat thing behind this is that we also have ability to upgrade the Lambda during deployment or maintain the current version. So as a security practice, you may have to evaluate the code that's in your environment and all that. You may have some CNAP applications that will look at it and you validate it, you confirm it, it's all good. But you want to make sure that you always have that same version. And this is one concern that a lot of customers had was that we approve it, but we don't want to automatically update it. So we have the ability to be static to a certain version of Lambda, which you never need to change, or automatically update. And Shay will go through that during the deployment process. As I mentioned, the whole overall design was a principal design around that is around decoupling infrastructure, events on scale, infrastructure as code, and guaranteed readiness for traffic, and of course, lifecycle management. So these are the five key principles that we try to follow here, right? So decoupling the services, so example, any changes to your environment does not affect everything else. So let's say you modify your Terraform code to be a different version. We want to make sure your Lambda function is static. We took that all into place. Consistent behavior across scaling events, right? So everything scales the same all the time, right? So if an event, something were to fail, we want to ensure that we have a way to first identify it and react, and then, hopefully troubleshoot it. So everything is logged within different locations. Infrastructure as code, we took the approach that, everything's done through Terraform or some CFTs, right? So we took everything at the 2R mode is infrastructure as code ready. And of course, guaranteed readiness for traffic. We don't want a Vox to go into production without being fully operational. So a lot of controls and checks around that. And then, of course, clean lifecycle management. The gateway's terminated. You don't want leftover content in your AWS infrastructure taking up additional costs. So everything is pushed, instance is terminated, that IP is pushed back to the pool, either IPAM or yourselves. So nothing left behind. So at Check Point, we are focusing on the four key pillars for AWS, and these are, both hybrid mesh, workplace security, exposure management, and AI security. So these are some of our offerings within this. And of course, we have a number of key products within our AWS marketplace. And many of these products, you could actually leverage your AWS spend or commit spend to help you as you go through your journey. So as you're deploying this into, let's say, an existing new environment, and you have AWS spend that you have to spend for the year, you could actually leverage Checkpoint products in these four pillars for those particular spends themselves. So don't have to always so you can actually use the spends as you move forward as you're going through your AWS journey itself. All right, Shay?
And
Shay, may I interrupt you for 1 minute? I'm sorry, but Evan is asking a question about the egress example that we showed.
he asked about ingress, not about egress, right?
Ingress, yes, I'm sorry.
Ingress.
Yes,
So you
exactly.
can see it over here on my screen. If you see my screen, we have here or a VPC with a load balancer. It can be application load balancer or network load balancer. Traffic will come from the internet to the application load balancer. The source IP is being hidden by the application or network load balancer and go to the target group. Let's say that this is the target group, and this is something that I'm going to show here in the lab. So he has a default route, not a default route, static route for those two subnet that point on the transit gateway. The transit gateway inspect the traffic and send it to the target group. And the route back is to the IP addresses of the load balancer. So it's going to the transit gateway, going to the same gateway, firewall gateway, and route back to the load balancer, and the load balancer send it to the internet. So this is for ingress.
That was well
Yeah.
explained. Yeah.
Yeah, I think with the ingress, there's, like I said, there's a couple of different options for that, as Shai just mentioned, is you could leverage the ALB or NLB, right? And as actually, I have a exactly as mentioned here. So it's just coming in. And the thing about the ALB and NLB, you have to use EC2 target groups. So this is actually a limitation within the AWS. If you use interface targets or IP targets, depending on if it's within the same VPC or not. If
So
you
what I'm doing,
use
since it's not in the same VPC on the target group, and this is what I've created here, is IP target group. It's not
IP
working.
target,
IP target group.
that's correct. If you use EC2 target group, it will not work cross VPCs.
Yeah.
So you can't actually direct that out to a transit gateway for inspection. So that is a limitation with AWS. So yes, IP target group is what you must use, and then both the ALB and NLB support both of those.
So let's move forward. So this is something that I already have those VPC and the instances, and also the transit gateway. The VPCs are connected via attachment to the transit gateway. And what I'm going to do now, I'm going to deploy the security VPC. So basically, deployment of, we are not deploying via marketplace. We have a dedicated SK with all the update CloudFormation template for our solution. You're not seeing this one now. And Guy, can you tell us when does everyone is going to see the new solution over here? I know that it was supposed to be released today, but we have a delay.
So we have a bit of a delay causing by the main train, and it's going to reach. It's expected to be mid-July.
Okay.
As for the latest update that I got. But as you said, the delay started today, so I think that in a few more days or weeks, the picture is going to be more clear.
Yeah. So this is go ahead. Sorry.
Sorry, Shai. I was going to say, so we are always, as mentioned, there is a delay of this, but we are always, if yourself as a customer needs this at early availability to test this out, help with the design aspects of it, we are here to work with you. We have many customers right now running this in our early availability. So don't delay the conversations. We are here to help and to migrate from a early availability to a general availability is just a matter of just really changing the AMI of it once it becomes available.
Okay, so basically, but you're going to find it when it's going to be released. This is the SK, this is where you're going to find it. So let's start with deploying it. I have a YAML file that I'm going to use to deploy this template. And this is the security VPC. Security VPC. The deployment prefix is Check Point. The gateway we support right now for the gateways, and Daniel, correct me if I'm wrong, R82, right?
R82 and
This
above
is
that, correct, yeah.
R82 and above. We choose a smaller size, C5 large is enough. The gateway SIG. Key name, I've already created a keeper. Management server, I will allow from everywhere, from anywhere. By the way, this session is being recorded, and I will upload this recording by the end of the week with all the questions to checkmates. Availability zone, you can choose, select up to 4. I will use 2 availability zones. Okay, this is 2 availability zones, but you can have up to 4. This is the default CIDR, and you can change it if you want. And we have a public subnet. It's going to ignore public subnet 3 and 4 because we have just 2 availability zones that I've selected. We have a private subnet. Those are those 2 subnets for the gateway, public and private.
האם אתה בלופ שנסטלה רוצים לחכות לפרויקט הזה של הדיסקים כדי לעשות...
Please put you, okay. And we have the Gateway Load Balancer endpoint subnet and attachment subnet. Attachment subnet, as you can see in each one of the VPC, we have attachment subnet that is dedicated for connecting the transit gateway. So we have the private transit gateway attachment, those are the attachment subnet, and gateway load balancer endpoint subnet. And if you want, you can have also, we have an option to deploy as part of the gateway deployment, to deploy also a management. But since I have already a management, so I'm not going to deploy a management. By default, where is the management? The management is management server setting, deploy management server. By default, the value is false. Okay, you have an option to deploy also a management server as part of this deployment. And this is the management CIDR. IPv4, we can have also dual stack IPv6. This is the IPAM pool ID. If you want to have a set of elastic, public elastic IP, you can set it over here. I will accept, I'm not going to change all of those settings. Enable AWS instance connect to allow SSH from AWS Web Console. It's always a good idea. Management server and configuration template. Those are for the CME. I'm going to show you how to configure. We don't use the Autoprov CFG anymore. We are going to do everything from the smart console. So this is the smart console and connected to the management, and we now can configure via the manage and settings. We have an options to configure the controller, the template over here from the cloud network. As you can see, AWS, the controller is already connected to North Virginia. You can use access key, or you can use STS role and also connect sub accounts. So I already set this up, and the value that you saw over there is in the advanced tab. Okay, this is the management name. This is the CME management name. It's not the one that we have on the gateway and servers. It's the CME management name, and it's need to be matched the management server over here. This is for the CME. So I will take this value, or the opposite. I will take this one, MNG CME. So for every deployment that you're going to deploy a scale set in the cloud, you need to use the same value that you see over here. Okay, he's going to tag the scale set with the management server name and also with the configuration name. So we'll copy also the configuration template name. You can change it here if you want. And I'm going to add a template. And the template should have the same name. And the version of the gateway is R82. And I will put the same SIG as I put over here on the top. So I'm going to use the same SIG. And you can also add the blades over here. You can do it also later on. Let's activate anti-bot and antivirus. And you see, for some reason, you see the gateway. I've done deploy a gateway earlier. But I don't have the gateways right now. Okay. So it doesn't see any gateways. You see one template, and you can have many templates, okay, for one controller. So let's move forward with the deployment. So with the management server for the CME, the configuration template for the CME. The CME basically is a service that, for those of you that are not familiar with that, it's a service that is running on top of the management. It's access of the cloud provider. And he check for auto scale with tag, with the management tag and with the template tag, and he is looking for gateways, new gateways or deleted gateways. And once he finds a gateway, he is going to update the gateway to register it inside the management, configure the blades, and also install the policy on each one of the gateways. Let's see it again over here on the template. You can choose what policy to install. Here you can see on the CME attributes, you can see what policy to install on the gateways. So the standard, this is the default one that is coming out of the box. This is the standard policy. You can find it over here. But for each deployment, you can also deploy a different package. So if you create a different package name for the policy, you can choose it from the drop-down over there. Okay, so I'm deploying the standard policy on the gateways. So let's move forward. Admin shell, cross-zone load balancing, it's true. It's may spike the cost. Minimum group size is 2 and maximum group size is 10. So we start with 2 gateways, and we will and the maximum number of gateways that will be scale up is maximum is 10. Password hash, I will put the password hash. The gateway address, you can provision them with the private IP or with the public IP. Since my checkpoint management has a public IP and doesn't have a VPN is the checkpoint. I will show you it over here. He has a public IP and he is not connected over a VPN to this security VPC or other VPC via the transit gateway. I'm going to provision it over with the public IP. Okay, so you're going, once he's going to register the gateway, you're going to see the gateway with the public IP. If he has a direct access to the private IP, you can provision them with the private IP. Management server false, so we can ignore all of this part is for the management. And Daniel, you talked about the Lambda auto update. So by default, it's false, and I'm going to keep it false. You can choose if you want to set it to true. I will keep it false. So next. And submit. So it's going to take for the whole process with the two gateways to be completed. It's going to take like 8 minutes to see the two gateways up and running and with the standard policy on them. So we will have to wait. In the meanwhile, it's now creating in the background, it's creating the VPC, the subnet, the gateway load balancer endpoint, the gateway load balancer, and so on, and the gateways. And what we will do now, we'll wait a few moments, and I'm going to connect this attachment, and is going to have two network interface, one in the attachment 1 on zone A, and another one, we are going to connect it to zone B. So let's go to the transit gateway and connect this attachment. The transit gateway is already connected to the ingress VPC and to spoke 2. So this is spoke 2, and this is the ingress VPC, and it's already connected. I've done it in advance. So let's go to VPC, transit gateway. Transit gateway attachment. This is the ingress, and this is spoke 2. And I'm going to add the first one, the security VPC attachment. Security VPC. The attachment type is VPC, and what is important to do here is to select also appliance mode support, because behind this VPC we have the Check Point stateful appliances, so we have to select this appliance mode support. The VPC is the security VPC, and I'm going to connect the US East 1A to attachment subnet 1. And US East 1B to attachment subnet 2. Okay, attachment subnet 1, which is this one, and this is 2, and create transit gateway attachment. What I'm going to do next, after the new attachment will be available, I'm going to create a static route. We have a route table that associate with the gateway load balancer endpoint. Okay, we have a route table with those two subnet. And I'm going to create a static route that say that if you want to get to the spoke, to the ingress and spoke to VPC, go to the transit gateway. And I can do it only after I created the attachment over here. If I don't have an attachment, I will not be able to see the transit gateway. So we need to wait for it. Okay, and this is for route back traffic. So once traffic is being inspected, it's going to the gateway load balancer endpoint, this one or this one. You see that the destination is 192.168 something, okay, class B. Send it to the transit gateway. It's taking a lot of time. Now it's available. Wonderful. So I'm going to route table. And we have the security VPC. And we're talking about the Check Point Gateway Load Balancer subnet. And the subnet association are the two subnet, Gateway Load Balancer subnet 1 and 2. He has a default route. He has a route to the local VPC. And I'm going to edit the route and add a route to 192.168.0.0/16. It's going to cover both the ingress and spoke 2. And I'm going to send it to the transit gateway. Okay, use the transit gateway. Now let's continue and let's take a look on those two subnets. Those two subnets, I've already created a route table with those two subnets. And we have a default route that point on the transit gateway. Just let's check that we have this route. And also for those two subnets on the ingress, I have also not a default route. You can also use a default route, but I've created a static route that point on 192.168.80/21 point on the transit gateway. So let's check those two. Route table, spoke to route table. It's associated with pod 01 and pod 02. And we have a default route that point on the transit gateway. Okay, those two have a default route pointing on the transit gateway. And also for those on the ingress VPC, we have ingress spoke route table with the two subnet. And for those I created to get to 192.168.0.0/20, which cover spoke 02, go to the transit gateway. You know what, let's keep it simple. I will remove this one and I will send 00 to the transit gateway. Okay, so it's going to be the same. Okay, so both of them, this one and this one, both go to the transit gateway. Now, traffic that goes from those two attachments to the transit gateway, we put the attachment, we associate the attachment with a route table. So let's create, it's over here. Let's put it to the back. So we have a route table that associates with these two attachments. And we have another one like that, another route table that associates with the security VPC attachment. Okay, so you will see that I've created in advance two route table inside the transit gateway. So you see transit gateway route table. I have two route tables that I've created. I have the spoke route table, and it's associated with those two attachments. Those two attachments, one of them is the ingress and one is the spoke. Okay. And we have also the security route table, and I'm going to associate the security attachment with this route table. So attachment can be associated only with one route table at a time. So create association, and I'm going to attach the security VPC. Okay, it's associated. So let's think about the route. What we are going to do is the traffic that is coming, let's say the destination is 888 in the internet, is going to the transit gateway. The transit gateway it's coming from this attachment. So it's looking on this route table, the spoke route table. The spoke route table, what we need to create is default route that point on this attachment, on the security attachment. So it's going to this security VPC. So let's do it over here on the spoke route table, okay? We are going to routes, and I'm going to create a route, static route 000, send it to the security VPC. Okay, to the security VPC. So it's going to here, and here it's going to the gateway load balancer, and why it's going to the gateway load balancer. Let's look on this route table that associated with the TGW attachment. So as part of the template, we are creating a route over there. So we have here the attachment subnet. We don't have a default route to the Daniel?
Which
default route?
So the attachment is connected to those attachments, right?
That's correct, yeah.
Okay, and from there you need to go to the gateway load balancer endpoint, point over
Yep.
here.
That's right.
So it should have a default route to the gateway load balancer endpoint, no?
Yeah. Can you show me the?
So it's 000 to the gateway load balancing A and E, that's A and B sec. So each of the transit gateways is going to go to the endpoint within the same availability zone.
The public. So maybe it's not created yet, or now it's created.
It is
Yeah. So
perfect.
here,
Exactly.
yeah, it was not updated. So we see
All right.
here on subnet 2, attachment 2 and attachment 1, we see default to the gateway load balancer endpoint in each availability zone. Okay. So again, it's landing here, and here we send it default to the gateway load balancer endpoint. He send it to the gateway load balancer, inspected over here, go to the internet, going back to the gateway load balancer, and going and land here or here. Here we created a static route that send it back. If the destination is 192, send it back to the transit gateway. Where does it land? It's land here. It's coming from this attachment, and this attachment is associated with the security route table. The security route table, let's go back to the transit gateway route table. And this is the security route table associated with the security attachment. So it needs to send it back to this attachment or this attachment. It depends from where the packet came from, right? So instead of create static route to each one of the attachment, we can do propagation. We can learn the route. We can import, learn the route, do propagation from those attachments. So how we do that? So on this route table, we go to, now the route is empty, right? So we do propagation. We need to learn how to get to the ingress VPC and to the spoke VPC, right? So we do propagation, and we are going to learn it from the ingress VPC. And also from a spoke to VPC. So what is going to happen if you are going to add more CIDRs? Is going to propagate automatically. You don't need to create a static route. Okay, so again, if I'm going now to the security route table, we have propagation, and we're going to see that it's a field. Let's wait for the second one to pop up. So this is the ingress VPC. We should see a second one. And we see the second one. We see also the spoke VPC. Okay, so those two routes were propagated. So let's go to the Smart Console, and we will see that we have the two gateways. Okay, and what is the problem with this one? Okay, so both of them are good. You see, both of them are green. So the CME saw those two new gateways, okay, on the scale set, and create the gateways. He configured the blades, and also install the standard policy. So the standard policy on each one of the gateways. So in case of a scale out event, a new gateway will be shown on AWS on the scale set. The SIEM is going to recognize this change and is going to register here automatically, install the blades, install the policy, and so on. And if a gateway is going to disappear, be deleted by the scale set, the SIEM is going to see that and delete the gateway from the management. So now, basically, what we can do is just test traffic. So we are going to have egress and also east-west traffic. So let's take a look on the last 1 hour. And let's go to one of the EC2 instances. So if I will go to the ingress, for example, this is the ingress 16106. Let's put it over here. So let's see. We already see that it's going to the internet, but let's connect to it. And let's run curl against prod 1 spoke 02 198.11. So let's ping to Google, which is working, and let's down curl to 192.168.811. Okay, and I have curl. You can see that I have the ICMP and also this curl on the port 80 that I have run. Okay, so we have you see that we have east-west traffic inspection between the VPCs. So we have traffic that goes from this one to this one. Okay, and also this one. This guy go to the internet, to Google. What I have here? Sorry. So we have this guy that goes to the internet, and also this guy ping to this one or on curl against this one. And for the ingress, I've already created over here ALB with target group of those two. And let's see if it's also if it's working. So let's check the target group. Spoke 02, you see that is healthy. And if I will go to the application load balancer, I will grab the DNS name. I will get the nginx server. Okay, so you see that we have also ingress. So basically, this is it. Very easy to configure. You have to understand the routing over here, but you're going to watch the video again, and you will understand that. I will share also this schema, this diagram. And by the way, if you want to do traffic, for example, if you have over here, you want to do a micro segmentation inspection, you can just deploy a gateway load balancer like this one. You can just deploy here gateway load balancer endpoint, do a route between those two subnets that point on this gateway load balancer endpoint, and this gateway load balancer endpoint can get a service from this gateway load balancers. You can connect them, and then you will have east-west traffic inside the VPC itself. Okay, so this is also something that you can do. And you can put here as many load balancer as you want. Basically, this is it. Let's see if we have any questions.
There was one great question someone asked about migrating from a single arm solution to a two arm solution. I
Yeah.
just I think it's we didn't cover it, but I do think it's something I want to just talk about quickly.
Mhm.
The diagram that's being shown by Shay right here on the right hand side, that we'll call that security VPC. If that was a single arm solution, you could actually deploy in parallel a two arm solution, and you could then attach that to the transit gateway. And then you can migrate one by one or all at one shot, or even just separate out your egress traffic to that new environment. So the nice thing about the transit gateway is that you could actually then define how your routes, as you migrate. So you don't have to you don't have to replace an environment, or deploy within the existing environment and try to make that work. Where if you just do it in parallel, you could pick and choose the traffic. So you could pre-stage everything, update your transit gateway routes, and then everything else on the VPC side will flow based to the transit gateway. So it's a very minimal to zero impact to transition over. Same thing with the gateway load balancing endpoints, as Shai just mentioned. If you have endpoints that are in an existing VPC, you can't replace the endpoint. You can't change the ID. You can't use a new gateway load balancing endpoint service the same endpoint. So you could actually deploy a new endpoint in the same endpoint subnet, and then you could pick and choose based off the route table the traffic you want to send to the old endpoint and to the new endpoint. And this could all be pre-staged also. So if, as a migration from a single to two arm, it's actually fairly seamless.
What you need to do is create, let's say this is the first deployment, and you have the second deployment. You need to create another route table on the transit gateway. So do it like that. Okay, so this is another route table, and you create the propagate, you create everything, and the last thing that you need to do is here in this route table, you change it, the default route, to point on this attachment. That's it. Very easy to do the migration.
Yeah, and it's quite common for customers to migrate only the egress traffic also. So this is something else to consider. If you're in an environment that you already have an existing single arm solution and you want to eliminate the cost of the NAT gateways, you could deploy this solution as a secondary security VPC and just have your egress traffic. So updating your route table on the transit gateway saying anything to the internet, go to the egress security VPC. And anything that's, let's say, east-west, go to the existing VPC. So it gives you a lot of flexibility.
Yeah. And if someone needs help with that, me and Dan will be happy to assist you, do a online Zoom session, and we'll help you with the configuration. It's quite easy.
One note I just want to take back is the only major change between this solution and an existing solution is the NAT gateway elimination. All the design recommendations, all the standard flows within AWS, all the route tables, they're all the same, except for we don't have a NAT gateway subnet. So you're not relearning anything. You're just removing that NAT gateway requirement.
Daniel, someone asked regarding the management, if you deploy pay-as-you-go management, I was told not all the management features are available with pay-as-you-go, and you need to bring your own license for those features. I'm not familiar with that. Are you familiar with something like that?
So the only thing I could think of is maybe remote access licensing, which would not be relevant in this case, and maybe DLP. But that's something not related to this particular topic today.
Okay. More questions, guys?
As I mentioned earlier, we have many customers in EA. We're always willing to take on more. If you're in a planning process and moving towards this, please, let us know. We have a lot of great security architects that could speak to this on point any moment. And then as you move forward in the future, this is probably be one of the most recommended designs.
Curtis asked if for traffic following between internal networks, are we still limited for bridge mode in restrictions?
No,
No. So we are two armed, we are route-based, not bridge anymore.
that's correct.
So, no limitations.
And someone asked about will this be available in GCP and Azure? Different design concepts. In GCP, we have a newer release that was released earlier this year called GCP NSI, which provides you more of a service insertion. So it is using Geneve. We use Geneve and everything in the background on this, similar to NSI, but it's more of an insertion instead of routing. So we do have that, very popular. And in Azure is a little more challenging. They do things differently. But if you want a product that aligns similar to this type of approach of a centralized VPC, you could do Azure Virtual WAN, which is what they're promoting for more of a centralized ingress point. Or we could also do more of a different type of concept. We do a security VPC concept, and Azure is different, and GCP is slightly different, but both of them can do things that are non-transparent to customers or to traffic.
So last thing that I will do on the chat, I will put my email and also Daniel's email. So guys, if you have any questions, you want help with this deployment or a switch to the 2-hour mode, just drop us an email and we will be happy to help you. So again, this session is recorded. I'm going to upload it to Checkmates by the end of the week. Thank you very much, guys. Thank you, Daniel. Thank you, Guy. Thank you, Nathaniel. And thank you, everyone.
Thank you all.
Bye-bye.
Bye-bye.
Thanks.
Thank you.
Bye.